Welcome back. I guess this time I'm live and we'll continue our series on Kubernetes and I don't know what all things are here. Okay, so we were following this particular tutorial and we were seeing how to do stuff. So we'll continue that. But let's start from let's actually learn how this YAML file is constructed. That's I think what we were trying to understand. By the way, just for the reference, so that all the people who are watching in the future, basically we did had a small stream before which was not successful because I got an urgent work, but we'll continue to that stream. In that particular stream we created an application, we created a Docker file which I will show you right now, don't worry. So where is my VS code? It's lost. Let's start the VS code. There you go. So we just created a Docker file of that application, and using this particular Docker file we are trying to create a Dockerized a Kubernetes cluster of, first of all, this as one of the pods. So one of the pods of our Kubernetes should be this one. So that's the target. So let's continue on that goal. Let's go back, start this again. Super. Okay, so for that particular purpose, I think we had to write something called a deployment.yaml file, and this was our deployment.yaml file, and it was not working properly. So we'll now see the documentation, the official documentation, and we'll see how to write the YAML file. So we'll see Kubernetes kubectl config file. Let's see how does that work. So we'll say YAML file. Let's see, do we get objects in Kubernetes? Yeah, we can create a YAML file. Okay, this is what the official documentation says, and I think, oh wait, for some reason my screen is not updating. Why there is always some or the other thing going wrong. We'll change the display for once and then we'll get back, and yeah, so we have the official documentation up and running. So we have this. So I think this will explain me what this is. So this is like an API version v1 kind deployment, and then, like, for example, you can do anything like nginx deployment. Then specs selector has a match label. Nginx tells deployment to run two pods matching the template metadata, whatever is the name, spec, container name, and you can put any image over there. Makes sense? Yeah. So some of the required fields in this particular configuration is API version. So let's read the documentation and eventually write the YAML file. So let's remove everything, right, and let's write the YAML file. The first thing which we need is an API version. It is like, what is the kubectl version we have? I think that's what it is. So API version. Amazing. Next thing we need is kind. So our kind is deployment. So I don't know what other kinds of config file you write, but yeah, this is what it is. And then is the metadata. Inside metadata, you can write the name. So for example, name could be learn k8 or learn k8 it's right. This could be one of the metadata. The next thing we need is a spec. Spec is like, I think, the final configuration of all the pods which you have. And let's say we only need one replica of the spec, right? I think replicas are the, yeah. And then we have selector. I do not get what selector is actually. What is a selector? Can you tell me? Selector. Labels and selectors. Yeah, there you go. So what is labels and selectors? Labels are the key value pair that are attached to an object such as pods, right? Okay, this is a key value pair. Labels are intended to be used to specify identity attributes of an object that are meaningful and relevant to the user, but do not directly imply semantic to the core system. Labels can be used to organize and select subset of objects. Labels can be attached to an object at creation time and subsequently attached and modified at any time. Okay, label is like hello, hi, random work, what's up? So label is like a key value pair which you can attach. That's the label. Got it. What is selector though? This is label, I get it. Yeah, so label will be basically, why do we need label? Labels enable user to map their own organizational structure into system objects in a loosely coupled fashion without requiring clients to store their mapping. Service deployment, so you could have like the various labels to your container. For example, you could have a spec for all the dev deployments, you could have a production deployment, and you could have various kinds of like various of these things so that you can manage them. I think that's the purpose of labels. I think so, not sure. So then we have syntax and character set. What is selectors though? So that makes sense, but so spec should have one replica, and let's not like care about this for now. Let's go directly inside spec and let's have a name. Name is nginx. So name could be anything. So learn like for example, let's say backend system. Right, so this could be one of them, and then we could have an image, and the image could be so let's see what images do we have. So we built the image previously using the Docker file which I showed you initially. So we can say Docker images, which will give us all the images, and the image which we are going to use is I think, I don't remember which was that. It's k8 backend. So this is the image we'll be using. Okay, the next thing which we need is, I think images are there. Next thing, what do we need? We need ports. So we want to map 8080 port, and let's try now to basically create kubectl, apply this, and then there is this error. So it says did not expect a key. Okay, what do you mean? At line number 6, okay. Did not expected a key at line number 8. What do you mean? What do you mean? So let's okay, so in the specs we have containers. Okay, that's the problem. So in the specs we have something called containers, right? Inside containers we have all these name and all these things. So let's say, let's forget about replicas for now. This looks good to me, at least. Yeah, let's see. Error from the server. Error when creating deployment. Deployment in v1 cannot be handled as deployment. Strictly decoding error, unknown field spec. What do you mean by unknown field spec? This is correct, right? I mean, what do you mean? Kind pod. Oh, so this is a single pod. So I can create a single pod configuration like this. Okay, makes sense. So this is a single pod. A single pod has metadata and a spec sheet. Okay, got it. So now if I go to this should make some sense. So this should make some sense. So this is like a deployment type which has various pods inside this, and then that has the name starboard deployment, and then you have this selector. What is selector, bro? Like, can you? It is a way for deployments to find pods. Oh, how will it find pods? We have given app starboard label. Okay, so anything. Hi Arjun Krishna, what's up? How are you? So we have app star. Oh, so this is a selector. So anything. I think it has to do something with like it will select all the containers having a certain, I don't know, let's see. So we have a selector and match label Star Wars, and then okay, then we have replicas too, and then we have a template. Okay, let's try to do this. So again, we want to create a deployment type. All of you guys who have already done like Kubernetes must be thinking, this guy is a noob. Actually, I'm a noob in Kubernetes. So, and then spec. So the spec which we'll have is, we'll have a selector. I don't understand the meaning of selector. If you guys know, please let me know. I really enjoy your way of learning things. All your videos are very productive. Thank you, Sasta Coder. Thanks a lot. I just accept. See, I just accept that I don't know this and I want to learn this, right? Even if I sound or visibly I sound very dumb, while figuring things out. But I think that's the fun of learning, right? You don't know some stuff and you just go and ponder it, like what is what, simple stuff. For example, even if I'm using like this selector thing doesn't make sense to me, I'm using it, let's see how will it make sense. Right, so we have a spec and we have a selector, and then we have a replicas. Replicas make sense, like how many instances of this do you want. For now, let's say I just want only one instance of this, and then we have template whatever. Let's accept the recommendation. So we have metadata kate spec whatever. Okay, so let's see, does it run? Oh, it created that. That was success. So I think there was some command to check stuff. Yeah, so we can say kubectl get pod. There you go. One pod is running, which is hello node, but error image pull back off. What does that mean? Image pull back off. How to delete all the pods? kubectl delete pod. So let's say I want to delete, like, does it have so if you look really close to the status of each pod, you might find something like error image pull, and yeah, we find that. So it will give us a log. Let's see what is the log. kubectl logs, and then whatever this pod name. So what we want to see is this one. So we'll just copy this. Error from server, container create in the pod, whatever is waiting to start. Image can't be pulled. Error image pull. Okay, what is this? I don't know. Let's see. So we'll do again. So to get the logs of all this, you do kubectl logs and then the name of the container. Error from the server, container is pod, whatever this is trying to pull. Okay, these are the images there. So if it is failing to pull images, you can spot the issue here. As you might have guessed, the Docker daemon in the cluster minikubectl, minikube whatever, runs in a separate Docker container in the VM. Is trying to find images that does not exist. We only create the image in above step for the logged in user. So we need to create same images inside Kubernetes cluster. What do you mean? Like, is it trying to find images outside? Like, give first two letter of the pod name, that will work. Thanks, Astakuda. Like, that's a good way. Like, I can try that. But like my three of them, all of them have the same first three letters. I think for the Docker name it works. So for example, for Docker container it works. So like if I write Docker PS, for this the container ID, if I give the first three ID, it works. But for the pods, I'm not sure. Like, you know, if I just do kubectl I don't know, pods get pod, this doesn't work because see, these three, like all three have quite like the same beginning. Now let's try to delete a pod. kubectl delete pod. Kubectl delete. How do you do that? So you delete pod. Okay. kubectl delete pod. And what do you want to delete? kubectl delete pod and the name of the pod, I think. Will that work? Let's try to give the pod. How to delete all of them? Ah, that's deleted. That's how you do it. That was easy. So then we want to delete the so can we delete all of them? Oh, yeah, all is cool. So there is a command called all, and now all of them is deleted. Oh, that was fun. So now we can do kubectl get pod, and it should give nothing. Wait, I deleted them, bro. Like I deleted them so that they should not exist. kubectl delete pod all for all. Yeah, it says deleted, but it's still showing the pods. I don't know what's the catch here. See, it's still container creating. I don't know, it's still showing the pods for some reason. Okay, let's forget it. We'll fix our this, right? So let's look at the tutorial. I think one of the things which we might be doing wrong is that this is okay. Yeah, so I think this is pushing the thing maybe to our Docker container. So this is basically, so hit so git build -t starvar node. Okay, so this is starvar node, that's the name of this, but your deployment stays there, should be replica. So think it's auto healing. Might be, that's correct, that might be the case. So not sure. Yeah, we'll figure it out. So we have we have like the local image of this particular whatever this guy is building is basically starvar nodes, right? So am I speaking too loudly? I don't know, I should. Yeah, that's better. I think that's better. We'll decrease it even more. That's better. Yeah, so we have something called starvar node, which is like the image of this, which is which the image which it is using. And where is the, so this is the place where you place the image. This makes sense. Okay, hold on. Okay, now I'm getting it. I'm getting a gist of this. Okay, so okay, watch this and tell me, am I understanding this correctly or not? Okay, so spec is like one thing which has children, right? So spec could be like a tree, right? So basically spec here, you can say this like root node, right, of this tree. And then you just doing a quick recap. Kriti, okay, so a quick I'm sorry, I'm pronouncing your name wrong. I'm pretty sure. What we are trying to do over here is we are trying to learn Kubernetes. Very simple. Very simple in one word. Okay, so so starvar node is the image name, which is correct, and then you have this some template, which is the root node. Okay, we can do this. I think I got this. I think I understood this one now. So we have the, wait, where are you lost? Here you go. So we have a selector, we have whatever match label with app, and then learn k, it doesn't matter, and then this will have just one replica, and then we have a template metadata labels app. Okay, and then we have a spec, and we have a container and name. Wait, why do we have this? So the image name is incorrect because this is not the image name. Oh, okay, now got the issue. I think so the image name which we were having is sorry, Docker images, and it was K8 backend. So I think we were giving the name wrong image name. So image, will give this one, and now let's try to do the same command, kubectl. What was the command name? Apply -f. Okay, so now this is configured. So if I do kubectl get pod, but no error. We just have one replica. What do you mean? Why do we have these many of them? Error image pull. That's the image name. Oh, let's check it. Let's check in our Docker container. This is images, and we have K8 backend. That's the image name, right? That's correct. K8 latest. What critical vulnerability were found in the base image? Whatever, we don't. Well, that is not of our concern right now. Why are you giving me this error? Let's try to do this again. Let's try to get the pods. So this is the one which I'm creating right now. Container creating. Is it live now? No. Oh, just say error image pull, whatever this error image pull. So get log. Let's see what was the issue. This is the one we were trying to do. Okay, so if I replace the image with something like which everybody knows, for example, let's say node alpine, right, whatever, like node alpine, like let's 3 point, what was that, 3.19, like let's see what happens. 3.19, this is like pretty well known image. So let's try to do this, and let's try to get the pod. Container creating. Let's see when it is ready. See, we did it. So first this is running. Our first pod is running. Crash loop back off. Oh, there's some other issue now. So go to node app folder again and run the following command. What is this? This is, let's try some other place. This doesn't make sense. Okay, so this is you're saying if you look at the status of each pod, you might see something like error image pull back off, and if you run into one of the k8's debug command like logs and describe pod whatever, if you do this, this will give you all the error, but this doesn't solve the error. It's for trying to exactly, that's the problem. We only created the image on the above step for logged in user, so we need to create the same image inside the Kubernetes cluster. Exactly, how do you do that? Go to your node app. Oh, it's telling me. Okay, so the problem is this is trying to find the Docker image inside the Kubernetes VM virtual machine which it has created, which is not possible because all the images are in the host machine, right? So we'll have to do something to probably give it the access or something like that. So it is asking me to go to that folder and then probably run these commands. Let's see what these commands do. Let's run them one by one. So what we'll do is we'll run the first one, which is eval. Okay, what did that do? Can you explain something, please? And then this one, so in our case there is no this, so it is backend. I think it's what was the name? It's, sorry, Docker file. This is the, what was the name of our container? I'm just forget. It's k8 backend. That's what we'll say, this k8 backend. And then let's now run this. Let's see what happens. So it build. How can it just build so fast? Docker build hyphen build dot hyphen t this. Yeah, it build to read Docker file. Oh, because we are on the wrong folder. Makes sense. So we'll have to go to the cool server and then probably run that command. This will now work. Yay, working. Okay, working. We're making some progress. And then additionally, you can check to see if the starboard Docker can also, you can do this. So additionally, you can check to see if starboard Docker whatever is in the, so to check is it in the minikube or not, we can SSH into minikube, something like this, which will give us the access. Okay, that's amazing. And now you can do Docker images. Okay, this is interesting. So what this does is, what that command that command did is basically give us, so this like eval whatever this we did, this enables us to go inside and perform like all the Docker build and everything inside what was the tool name, minikube, right? So it performs inside the minikube, and then we basically when we build it is generated. Oh, that makes sense. Okay, in the sw.deployment.yaml file, add the following line. Okay, so then this makes sense now. Whatever. So now what we have to do is we can change this to exactly what it was before. Is it there? Yeah, k8 backend. So now this can find, I think, because yeah. So name image will be this, and latest is not required, I think. So this is there, and now it is asking me to add image pull policy never. Image should not be pulled. Makes sense, because image is locally located, so why to pull it, right? And now you need to start over. Let's delete this existing deployment and rerun the pod creation. Go to folder. Okay, so we can get all the deployments by simply doing kubectl. Oh wait, how can I exit this? Yeah, cool. So let's go to the root folder and now say kubectl get deployments. This will give me all the deployments. There are 3 deployments. Now what we can do is we can delete the deployments. We can say kubectl delete deployment, right? And we can say hello node or whatever we have. So let's say hello node. We have deleted hello node. We want to delete the learn k8 as well. Learn K8s as well, and then learn K8. So I've deleted all of them. So now if we just say kubectl get deployments, this should give us all the deployments. So we don't have any deployment because we have deleted all the deployment. So we can see we don't have anything. The next thing is what we have to do is we have to again generate a new deployment because we'll be deleting the previous one. So we'll say kubectl apply -f deployment.yaml file, and that basically created. And now what we have to do is we have to get the pods and check whether are we successful or not. Yes, that means our first backend pod is running as expected. So that's amazing. We have our pod running. So now service. So now you have two pods running. We don't. So currently, as because we only wrote like one replica, so there's only one pod running. This was simple though. This was not very complex so far. Like I really got the gist of it. So yeah, we have one service running. Amazing. Then we say service. So what is service? Let's see. Let's read. Now we need to connect these pods. Each pod has an associated IP address. But if we attempt to use these IPs to connect, it will become unmanageable when the number of workers, worker machines and pods increase. Here is where the concept of services comes. It is an abstraction to access pods without relying on lower level details like IP addresses. So makes sense, right? Here, let's say you have a front end, a back end, some different backends, because it is microservices, right? You could have like 50 different backends, right? Backend services are running at a time. So you cannot access them using IPs, right? Because that's very hard. You cannot remember 50 IPs, and also they keep changing and all. That's very hard. So we'll see what is the solution. So for that, this concept of service has been introduced. Let's see how does that work. So let's learn more about service. In Kubernetes test folder, create another file called swservice.yaml. Okay, so we'll have to create some other file. So we'll say I don't know, k8.service. So let's call it service.yaml file. Service. So we have created a service file, and then this also requires some API version, right? So we are learning in bits and pieces, and then we will be finally having a final version of this. So we are using the version 1, and this kind is of service. Now I get what kind is. Okay, so if you have to create deployment, the type should be deployment. If you have to create services, it should be services. If the type if you have to create pods, then the type should be pods, I guess. Metadata name, I think format is same, so we can call it anything. Learn K8 service, like we are learning service, so we'll name it service. And now we need to write all the specs of this. So what all specs do we want? First is a selector, which I absolutely don't get what this is. Is it like associate? Okay, so SW service, and then selector app Star Wars. So I think this will be same in this. I think so. Yeah, I think it has to do like something with the way you bundle your app up, maybe. Not sure. So selector, I think the selector should be same. So learn K8s, and we have here also we have written learn K8, so that sounds correct to me. Next thing, once we have that selector, we'll be having a type. So this is of type load balancer. Okay, makes sense. And then ports, TCP port, saying port 3000, but we want to run at port 8080, I guess, not sure. Let's see, index port 8080, yes. So we want to, and target port 8080, that's correct. Okay, so that makes sense. It is like in normal Docker, like this is the internal port, and this is the external port which you would like to keep. Makes sense. What is node port? I don't get it. Selector of a service as name of deployments, right? Selector of a service, same as that of deployment, right? Right, exactly. That's the same. I guess it helps you, like you build your service separately, you build your deployment separately, and you build your pod separately. So it's just like a bundling so that all of them can act together. You use a selector. That's at least my interpretation. That's what I have understood so far. That could be something else as well. Okay. So I don't know why do we have a node port. I don't get it what node port is. Do we have a node port? So the node port is the port that can be used to access the service using external IP. Note that there is a range of node port. Okay, so let's mention this node port. Who cares, right? Right, and this uses TCP protocol, right? Okay, so now what we'll do is we'll save this, and we'll say kubectl apply hyphen apply hyphen f service.yaml file. I think, oh, it has created. So now you can say kubectl get service. Now this makes sense. The command is also quite similar. So this is our this has created a service. Makes sense. Yeah, it has created a load balancer and a cluster IP. I don't know what these two are. Now what you have to do is okay, let's see. And then you have to run this command. Okay. Existing due to SVC not found. In our case, this doesn't work. Minikube services as do. Oh, so the name is incorrect. Okay, makes sense. So this is not the name which we gave. The name which we gave was this one. So we'll have to change that from this to this. Okay. Great. Because of you're using Docker driver on Darwin, the terminal needs to be open to run it. Okay, that's okay. And now what I can do is I can simply go to this URL, and this should give me the it's saying external IP. What is the external IP? Should be our own. Service name should be our own. Exactly. So now I've updated that. So service IP address. So service IP address is which one, by the way? Is this the load balancer one or the cluster IP? Let's try the load balancer one. I think this should be the one. And let's remove the curl, or we can do it in the terminal only. Let's do curl http dot, right, this is the IP, and we'll be accessing it at port 31,000. And if you're thinking what should the result of this particular stuff should be, it's if you go to index.js, you'll see like @ I have a JSON. I'm returning a JSON which is like this, right? A hello. But it is not working. So we'll try different ports or different, like maybe the IP will be the like I might be using the wrong IP. Oh, this is giving me this. Okay, I might be using the wrong IP or something like that. So let's try this, and let's say curl. Yay! Yeah, we did it. We created our first Kubernetes. This is exactly the message which we expected, right? I would like to show you guys, but we'll add more complexity to this. But yeah, this is our first win. So this is one of the pods, and I think there should be some control panel or something like that which should enable us to see. Then we have a config map. If you remember, we defined an environment variable max star was character in node server. I added this with purpose. The reason being introducing the idea of config map, another object type in Kubernetes. A config map can be used to handle environments related to a container. Okay, that makes sense. So okay, so this is like passing data to a particular so you can configure this. Okay, this how can I use this though? So let's use this, and then it might make sense. So we have created a deployment, we have created a service. Next thing what we'll do is we'll create an environment. So we'll say ins.yaml file, right? And now this is API version v1. API version v1, right? And then what we can do is we can say kind config map, right? So this is a config map, and then metadata, we can give a name to this. Maybe envs makes sense. Yeah, that's the name we would like to give. And the next thing what we would like to do is, what is a data? So we can pass any data. Like, does that like that is what does it mean? So let's say let's give something. Let's give some environment variables. For example, let's say message, right? So let's say message some, like whatever, some sample sample message, right? Something like that. And after that, what I'll do is, so now you should be so just as above, we have defined API version, kind, and meta attribute. Okay. So now there should be a way to inject env to starboard node. It is done by adding container.env file in the okay. So you have this YAML file. Key value pairs, I think. Yeah, exactly. This is like .env file, environment variables. So then what you do is you create the environment. So I think this is very simple. So we can say kubectl apply apply -f, and we can say environment.yaml. Yes, so that we created that stuff, and now we can, I think there will be some way to mention this in the service. So in this service we were, no, not this service, I mean in the deployment YAML file. So how do we do that? Let's see. So we do this, and then what you do is you after ports you could have an environment, and you can say, you could have a name, and you can say message, maybe, I don't know. Why is it so hard? It shouldn't value from. No, I think, I think whatever your name is. So the thing is, what happens in a normal production environment, you might want to have different environment variables as per your deployment. For example, for a dev server, the environment variables could be totally different as compared to your prod server. So there's basically, this deployment is like one such deployment. You're getting it, right? So yeah, so this gives you to create like ints. So there could be one environment for let's say your development server, there could be another environment for your production server, and you can create two different deployments based on that. So yeah. What this is telling you is value from config key member ref, name is envs ints, and the key is message. What does this do? I don't get it. Oh, so the name, okay, so the name of the environment variable which we want the value of this from is ints, and the key is message. Makes sense. This completely makes sense. See, so the name of this environment is message, right? The name of this environment is message. So the value of this message comes from an config map ref. So like, some config, you are referencing some config map, right? And the name is env. So what is env in our case? It is the name of this. So it's env. So if there will be something else, the name of this will be something else, then we'll be using that. And then out of this, all the environment variable we have over here, out of all the data, what do we want? We want messages. So it was simply like, we get the message, I guess. Yeah. So now what we can do is we can apply this. So we can say kubectl apply -f. I think what was that? This was deployment.yaml file, and great. And we should be able to see. So now we should be having the ability to access this. And let's see, is it like normal environment variable or it's something else? So to check that, we'll have to see how this guy has created his. Oh, so this is the thing. It's the environment variable. Basically, I was correct. Okay. So to prove my point, what we can do is we can just go to the application, and I think let's return the value from let's say env. So environment variable, I can say process.env. I think message is what I defined, right? So this is what I defined, message. Now what I can do is I can so to access this, I'll have to rebuild my image basically. So now what we have to do is we have to run this command called eval bdcube, and now we'll have to build our container. So this will be available inside mini cube ssh. This will give us ssh, and now AngularJS cha aayega sir. What do you mean? Like, when will I create videos about AngularJS? Is that what you mean? Docker images, and let's see, do we have that image? Do we have that latest image? Let's check the date when it was created. So it is like saying 22 seconds ago. That means like we are good. And we can say exit. I don't remember this command. What's it? It's called docker env, simple. So minikube docker environment. Okay, got it. Okay. So after this, I think as we have rebuilt this, do we need a redeployment? I don't know. Let's try to apply this again. That might like mini kubectl apply -f. No, not at this folder though. So we'll have to go to, yeah. So is unchanged, but we want to redeploy. Will it directly work? Let's see. So if this directly works, right? So we'll restart this. And we have this IP address, whatever this is, and we'll say curl. I think the port has changed for some reason. Yeah, the port has changed. Let's try to do curl this exact command, and we got hello world. This is not the new app, so there's something wrong. We do not have the new app there. I think we'll have to restart the cluster somehow. Let's see. Does this talk about restarting stuff? Do we need to deploy this? I think we'll have to delete this deployment. So we'll say kubectl get deployments. This will give us all the deployments, and then we can say kubectl delete. Not this one. I want to delete deployment. Delete deployment. Learn k8s. Great. And let's try to apply this again. Yeah. Okay. So now we'll have to run this again because this is annoying. Hasn't redeployed. Yeah, exactly. It has not redeployed. So I think there will be some short command to redeploy. So we'll say curl. Yeah, you can see some sample message, and we have successfully passed the environment variable from this whatever that okay, kubectl rollout restart deployment my deployment. Okay, that's interesting. I'll try that command. Let me try it up right away. So kubectl rollout restart deployment, and then whatever the name of your deployment is. My deployment's name was, what was the name of my deployment? Kubectl get deployments. This was, and then we can say kubectl rollout restart. Can we do restart or like without rollout? I don't know. Will this work? Deployment learn kate unknown. Okay, so we'll have to do rollout. So rollout, it says cannot find, so I must have misspelled it. So it's a kate. Yes, you're true, bro. That was a correct command. So we'll have to use kubectl rollout restart deployment and the name of the deployment. We got it. So let's summarize what we have learned so far. I think it was quite fun. So, and then we'll proceed ahead with more complex stuff, right? Summary.md, right? Whatever we have learned. So let's make it a little bit better. What did we learn so far? Like how to create deployments, right? We learned this. Then we learned how to create services. Then we learned how to create environment variable files. I think that's a bad name for what we did over there, but that's like environment variable. We learned all these three things. So let's have a look at the services a little bit more, because I think I did not understood this properly. So what does services do? So we created this service. Okay. So now just at an advanced step, let's let's add one more React application to this, and let's try to add all of those configuration, and let's try to make a communication between the React application and the Node server which we have. So let's see, can we do this like as a next step or not? So what we'll do is we'll create a new folder and we'll call it, oh, so we can just create this using this very fancy command. What was that command name? Yarn create Vite. This will help us to create a Vite application. What should we name this? Let's name this Frontend app. Right, this will be a React application or vanilla. Let's create a vanilla like JavaScript application, like very simple application, nothing very complex, right? So that we can see how does this work. And then what we'll do is we'll go to this whatever front end application which we have, and I'll just show you what do we have in the application. We'll have to install stuff. I think first let's quickly install stuff. Let me drink a little bit of water. And how are you guys? What are you guys learning? Okay, so we have yarn installed. So if I just run yarn dev, you will see the default app which it provides. So this is the default app which is provided by. So let's Dockerize this app very quickly. So we'll write a Docker file for this front end application. So we'll write a Docker file. Amazing. We have a Docker file, and now what we'll do is we'll just cut this off. We'll say from learning sales. That's an amazing skill. That's a good skill. I think computer science and sales, these two things are really are gonna fly in the future. So let's do node alpine. I don't know, alpine 3.16. I think that was the port we were running. 3.19, not 3. Oh, so let's copy this line from there. I think we can just copy these till like all these lines. So we can do this. This will kind of like fetch that image. So we'll create app as a working dictionary, copy package JSON, install stuff, and then what we're gonna do is we're gonna build this. Is build a step in this? I'm not sure. Oh, we do have a build process. This is the build, right? So we'll have to build the application next. So run yarn build, we'll build this, and then what we'll do is we'll just then I think we'll have to use nginx for this, like node with nginx maybe. No, we can run yarn preview, which will basically launch it. I don't know, yarn preview, run yarn build, yarn preview. This 4173, that's the port on which this runs. So we'll run yarn preview and then cmd yarn start, not yarn start, yarn preview. And then expose, not port this one, but port, what was the port? 4173. Right, that's the port we would like to export. This is very simple, very simple Docker file. Let's try to build this Docker file. Do we want to build this like right now? No, I don't, like directly on the host machine. No, let's build this inside the kubectl. So what we'll do is for that you'll have to run this command, eval minikube docker env. This will, yeah. So now what we can do is we can see docker build .-t, and let's call it I don't know, learn k8 frontend. Right, let's see. So it's running the commands and all those things. Yarn install. So at yarn build, this basically failed for some reason. Could not resolve entry file index.html. Oh, because I did a very stupid thing. I did not copy the content. So let's, after yarn install, what I need to do is I need to copy the content. Okay, this is the step which I forget. So we'll run this again probably. 4073, that means that should be pretty fine. Okay, is it stuck over there? Yeah, it's stuck. I think we'll have to learn a little bit of nginx image. So let's see. uh let's see how do we do this. So for this, I get it. Now that we have our server is running on port 5000, now we can configure nginx proxy to request to it. First we see that port, what port nginx is running on. We'll need to locate the default nginx.conf file. But what is the docker file? What is the docker contain? What's the... Yeah, this is what I wanted. So, oh, it's using the normal node image. That is quite good, and it's using some kind of file structure for now. So the first thing which it tells me to do is set up nginx. First to see what port nginx is running on, you'll need to locate the default nginx.conf file depending on the distribution. The file could be located in the following, whatever this. So we are using the same. When you locate the file, it will be looking something like this. I omitted a lot of lines and replaced it with whatever this. So we'll be looking like this. Okay. The important line to look at is configure nginx to be reverse proxy for the node application. Okay, this is cool. So this is the default configuration. Let's try to use this. So we'll have to create a new nginx folder. Inside this, what we need to do is we need to do default dot conf. So all of you guys who are wondering what is nginx is a proxy server. And what is a proxy server? It basically reroutes requests to various parts of your internal application. So it receives all the external traffic, and then you could distribute it within different services running inside your container, right? So it's like a policeman who is, and it also sometimes work as a load balancer, but that we're gonna not talk today maybe. So let's copy this, copy, paste. Yeah, that's the so it's running on default port 80, and this is, oh wait, proxy pass web app. What do you mean by web app? What is the docker file? There should be a docker file over here. Yeah, there is a docker file, and using node alpine, everything like that. And then it copies, so it copies package.json, install, and copy, and then start. That's incorrect. So that's not what we want. I think this is not the correct way, but we'll just pretend this is the correct way, and we'll so by default port 80 is the open port. So yeah, will not expose any port, and so proxy servers plus capacity estimation is equal to load balancer. Yes, exactly. So okay, so let's talk a little bit about this. Let's forget about this one. So let's say this is your whatever, like this is your box, right? And a lot of traffic is coming, right? You have a load balancer. So you could have just one machine and just a load balancer, right? And you could have a lot of services running inside this, right? What you could do is you could be having the same services replicated like n number of times, and then you can distribute the load based on different strategies, load balancing strategies which is available. So your nginx could work as a load balancing like server. So I think Kubernetes itself has some load balancing strategies which we're going to see. But let's continue on this one first. So this is doing this. So serve static serve static content in through nginx. Let's do some let's serving some static HTML files. Let's see. Serving static content. So root dictionary and index file. So this requires some root dictionary and you can serve some static contents. Okay, so what we'll do is we'll go a little bit smarter. I think that idea that GitHub was like the solution which was there in that GitHub was really dumb, so we'll not follow that. We'll write our own solution. So what we'll do is we'll take we'll only build this till here, and we'll name this particular Docker file as base. So this will be our base. So from whatever this is as base, right? And then we'll have another Docker file. We'll say from nginx, whatever this is, alpine, right? So we can copy the build folder to this particular folder, which is HTML, and then expose port 880. I think it by default serves this thing. We'll see does this work or not in a while. So let's quickly like build this. Let's see what do we get. I think it will fetch the nginx. We don't have that nginx image. It might fetch it. Again it crashed. Copy from base. Failed to compute cache key. Failed to compute checksum from whatever this is. Build did not found. So it cannot find /build. I think it's /dist, not build. Now this will work. Yup, this works. This works. So now what we'll do is we'll try to run this. So we'll say run. Should we try to run this? Let's try to run this. So let's go over here. Let's go to images. I think the image will not be over here. So whatever that front end image it will not be here, because whatever we are doing is inside the container. Now let's try to add this front end like front end to our service. So we'll go to the deployments, right? And we'll add one more container, I guess. We'll have one more containers. Also containers. Okay. There should be one more over here, I can say, probably. And then this could have some name, maybe. Could we give this something else? That could this have like a backend, right? And then we could have like this as front end, right? And then what we can do is we can give some image. So what was the image? Docker images. If I can see this called learn Kate frontend. I think that was the new Docker image name. And then what we can do is we can have ports. So we want the default 80 port to be exposed. And then image pull never, so that because it's locally located, and we don't have any environment variable, so we can skip the environment variable part for now, right? So this is the second thing. Now we'll try to deploy this. And how many of you think this will work at the first go? I don't think so. Nothing works at the first time, right? So I can say docker kubectl apply. I think that's how you do it, right? No, we are at the wrong folder, so we'll have to go back. kubectl apply deployment.yaml file. Oh, it worked in the first go. Amazing. It worked in the first try. Okay, so we have this whatever deployment.yaml file, and now what we can do is we can see is it working or not. How we can see? We can get kubectl get pods, right? So we'll get the pod, and it's saying it's running properly. Why is it like saying 2? Like it should be 2 different pods, right? That's a little sad. So we have this, but I think we'll have to update our services as well. Let's see, what do we have? So we have app learn Kates, and then we have a load balancer, and we have ports, and then protocol TCP port 8080, node port 3100. But then How does this work? So what does this mean? Like if I start, will at port 80 will, does this combine all the ports of all the machines, all the pods? I don't think so. That should be possible. At port 80, hello. This is the same message we are getting from our backend. So there's no front end in this. How to do this though? So we have our metadata, we have kind, we have API version, and we have name and specs selector. Then we have a port. Okay. I mean, could we have more of these? I don't know. Could we have one more TCP, and maybe we can have port 80 and, you know, at node 3100. Maybe this might work. Let's try kubectl service apply service.yaml file, and it says name is required. So ports, where do you see specs ports name? We'll have to give name. Is this how what do you mean? So this is the backend and this is the front end. Is that what it means? Yes, that is exactly what it meant. So now what we can do is we can try to probably restart the service. So we can say kubectl service. I don't know what, how did we do that? How do we mini service URL? Yeah, it's running at two different ports. I don't know why, but what do we want? Let's try both of them. Let's try this one first. What do we get? Oh, we did it, bro. We did it. Our application is actually able to query to like whatever, like query to other. Great. So now let's try our like to use that same API which we created, the root API from our front end, and let's see how does that happen. So yeah. So we have the front end app. So we'll go to index.html file or main.js file, right? And let's quickly try to simply replace the body of the app with the response of that particular stuff. So we'll say window.onload, right? We can just say this is an async function, right? And then what we can do is we can just fetch from that particular API. So we can have some response is equal to await fetch. I don't know what URL should I use. So I think I can use directly the name of that application. In my case, it is, if I go to services, I might get it. So what is the, no, I need to go to the deployments, and then I need to see what is the name of the, so the name is K8 backend. So we can call it K8 backend, right? And we can give some port. So this runs on port 8080. So probably I assume this will be port 8080. And then we will get some data, which will be await response.json. And then what we can do is we can say body, we can say document.body.inner HTML. Inner HTML is equal to json.stringify this data, right? Right. So we have fetched the data and stringified it and set it as a JSON. So we'll have to probably restart our entire container for this, but we'll do it. So we'll have to say eval, whatever this is, but for this we'll have to go inside the front end folder, and then we can say kubectl no, kubectl eval this command, and then we'll have to say docker build dot -t dash t, I don't know, dash hyphen whatever, that thing, and then will have to use the same front end app like image name. I don't remember the image name, so we'll take it from, so this is learn k8 front end, I think that's the image name, and we'll rebuild it. I think having a Docker compose over here would have helped a lot. Probably we will build the Docker compose right now, but let's first, like, let's continue for now. So we'll say Docker, okay, so we have rebuild. So I think we'll have to restart our cluster now. So kubectl, not this one. What was the command? I think the command was rollout, restart, deployment, whatever the name of my pod was. What was the name? I don't remember. kubectl get deployments, which will give us all the deployments, right? So we have learn what k8. So now we can say kubectl, we have deployments, and we have so we want to say rollout, restart, deployment, and then learn k8. It says restarted. I don't know, will this work or not? It's not working. Oh, because I think this we'll have to do mini cube. We'll have to start the service again. So we'll just start it again, and we'll try to go to this URL. Let's see what do we get. I think it failed. The network request failed. Yes, it failed. So it failed. But this is running. I mean, this is definitely working, but I don't know how to do the inter pod communication. So let's do a little bit of Googling on this, and let's see how we can achieve that. So inter pod communication in K8. How do pods communicate in K8 Kubernetes? Let's see. How does front-end pod communicate with back-end pod? Exactly, that's my question. How do you do that? So pods usually connect with other pods through a service. Okay, so that means, you know, we can simply name this, so we can call it backend dot whatever this is. Okay, that's interesting. So now what we can do is we'll have to go to our main.js file, and now instead of this we can just call it backend, because that's what our services, like that's what our services hold. So we can save this, and let's see what do we have in services. So we in the services we have backend that has port 8080 and that has target port 8080. So that should work. Yeah, maybe not sure. So again we'll have to rebuild stuff. So we'll have to go to our front end and do that stuff again, and docker build whatever this is. We'll be rebuilding our application. Again, we have successfully rebuild our application. Now what we can do is we can restart our cluster. So we can say kubectl rollout restarted, and we should be fine now. Oh, still not working. Interesting. Oh, because it's not running. It's not like it's not okay. Makes sense. So we'll have to start our service. So it's saying SVC not found, service default. It's just angry at me for some reason. Mini cube service list. Okay. So this basically mentions what is the name of the port and to whom it is available or something like that. So what I can do, this is service list And I think one, like, there is some place where this is already running, maybe. Not sure. Why is this failing? Let's restart our like. Oh, the name is incorrect, so it's not SW whatever the service is. Our service name is something else. So what was the name of our service? It's learn Kate. Yeah, that's what we more of what we want. There you go. So now if I go to this, we should be good now. It's not giving me some. Oh, so the backend is failing. Why is this failing now? Because it's making a request from the front end. Interesting. Let's read the full article. So it's saying create the pod and give it a label. The pod is usually created through another object like deployment or stateful set in OpenShift, whatever this is. So app API, create a service which selects the backend pod. The app communicates with backend using service name as the host name. So whatever the service name it. So that's exactly what we are doing. How do containers in the same pod communicate? With localhost makes sense. Pod to pod communication, that's what we want to learn. Understanding pod networking. Pod in Kubernetes are assigned unique IP addresses within the cluster, enabling direct communication between them. By default, each pod is isolated with its own IP address, which allows for secure communication and avoid port. The problem is, I'll tell you the problem, right? I think so in the front end, my browser is making a request, right? So that needs to be, so that let's see. But this was a good progress, right? We were able to learn the deployments. We were able to learn the services. We were able to learn the environment variables, right? uh, Probably I'll close the stream right now, and we'll do it again tomorrow from like morning. I'll probably do more research and we'll come back. So yeah, I'll be closing the stream. If you guys have any question, feel free to ask. Otherwise, bye bye. Great, man. Thanks, random person. Tomorrow, what time? Tomorrow, probably in the morning at 12:30 to 1, we'll start, right? And we'll continue till evening tomorrow. That's very correct. I was actually going to delete this video, but as Arjun said, will not delete now. Okay. Thanks and bye bye. Have a great day. Bye.